Hello friends, in this video we are going to see how to draw the Lewis dot structure of a molecule and determine whether the molecule is linear or not. So let's get started with a simple molecule N2O. So step 1 is to find out the total number of valence electrons present in the molecule. So the total number of valence electron, so the molecule contains 2 nitrogen, so 2 times 5, so nitrogen has 5 valence electron plus 1 oxygen, 6. The total number of valence electrons is 16. Step 2 is to identify the least electronegative atom. In this case, nitrogen is least electronegative when compared to that of oxygen. So we are considering one of the nitrogen as least electronegative and make it as a central atom. The next step, arrange the rest of the element around the central atom as per our convenience. So step 1, you have to find out the total number of valence electron. Step 2, you have to identify the element with least electronegativity and make it as the central atom, and arrange the rest of the element around the central atom as per our convenience. Now next step, you have to make a bond connecting the rest of the element to the central atom. In this case we have made 2 bonds, and we know that a bond is nothing but a pair of electrons. So we have made 2 bonds, so we have spent already 4 electrons. So you subtract it from the total electrons. So we have to add 12 more electrons into the molecule. Now we are going to add them as lone pairs over the elements. So how do you follow it? Is that you start filling up from the high electronegative atom to the least electronegative atom. Or in other words, we can say that start filling from the outside, then fill to the inside. So now we have added 12 electrons into the molecule, and next step is to check for the octet of these elements. You could see that this nitrogen has attained octet, oxygen has attained octet, whereas the central atom has only 2 pairs of electrons. So what we are going to do is that we are going to transfer the lone pair from the nitrogen and make it as a bond between the central atom. So we are just going to remove these electrons and make it as a bond between the nitrogen. Now if you check for the octet, this nitrogen has octet, even the central has an octet. So the structure drawn is stable. We can cross verify by calculating the formal charges of the element involved in the molecule. The formula to calculate the formal charges is given by just the formula is given there. So formal charges is given by valence electron minus the number of lone pair of electron minus the bond pair of electron by 2. So in this case, let us start for calculating for the first nitrogen. So we know the number of valence electron is 5 minus 2 minus 6 by 2, that is 0 for the first nitrogen. For the nitrogen in the central atom, it is 5 minus 0 minus 8 by 2, that gives you plus 1. And for the oxygen, it is 6 minus 6 minus 2 by 2, that is minus 1. So the algebraic sum of the overall charges of each element is 0. So even that matches and says that the given molecule is neutral. So how to find out whether the molecule is linear or non-linear? It is simple. This molecule is linear. The reason is, you could see that there is no lone pair over the central atom. So I repeat once again, Step 1 is to calculate the total number of valence electrons. Step 2 is to find out the least electronegative atom and make it as the central atom. Then arrange the rest of the elements around it. Make a bond, distribute the remaining electrons as lone pairs. Shuffle up the electrons to provide octet for each of the element involved in the molecule. That will give you a stable structure. You can cross verify by calculating the formal charges and check whether the sum of the formal charges is equal to the charge over the molecule. And last step is you can find out whether the molecule is linear or non-linear. In this case it is linear as the central atom has no lone pair. We'll see one more example that is similar kind. We'll see one more example. It's ozone. So step 1 is to calculate the total number of valence electron. In this case it is 6 into 3, that is 18 electrons. So all the 3 elements of same electronegativity, so we choose one of the oxygen to be the central atom and we are arranging the rest around it. And next step is we are making a bond to connect them. So we have spent 4 electrons for making 2 bonds. So remaining is 14 electrons. So we are going to add the 14 electrons into the molecule. As I said earlier, we are going to add these electrons from outside to inside. Now we have added the 14 electron equivalent. So again we have checked for the octet. In this case you could see that the outer oxygens have octet whereas the central atom has no octet. So what we do is that we shift a lone pair as a bond into this. So you could see that now even the central oxygen atom attained octet. So the structure drawn is stable, and then we can even check for the octet. We can check for the formal charges. So for the first oxygen that we are going to calculate as 6, that's a valence electron, minus 4, the number of lone pairs, minus 4 by 2, that is 0. For the middle one it is 6 minus 2, 6 by 2, that is plus 1, and the last one is 6 minus 6, 2 by 2, that is minus 1. So the sum of the overall charge is equal to 0 and shows the molecule is neutral. Is this molecule linear or non-linear? Good, it is non-linear, and the reason is you could see there is a lone pair over the central molecule. I hope you enjoyed watching the video and learned the concept with ease. Thank you for watching.